Welcome everyone to another live video here, friends of good old vintage rare and exotic hardware, not only Sgi Octane and PS3 but also good old-fashioned PC stuff. Case in point, today we got here a somewhat rare number 9 Visual Technologies Imagine 128 successor in terms of Revolution 4. Here only real with number 9 logo. So why is it somewhat rare? So not only, of course, they were somewhat successful in the 80s and 90s, number 9, and they also used others, chips like TI in the 80s and CAD accelerators, or the beginning of the 90s, and then also later. However, they also had some of their own integrated circuits. Here this Imagine 128 or this Revolution 4 successor. And of course in the 90s with popular cards like the Voodoo and S3 Verge, as much as it was in de-accelerator, the S3 was still very popular, having such a market share in general, and then people just buying it for the 2D graphics in Windows and getting the 3D de-accelerator for free. So not that many quantities sold, at least not compared to Voodoo and later Nvidia and such. And this card in particular, so I usually try to get here for my own hobby and this YouTube channel a little bit interesting cards. This is particularly interesting. Not only is it nearly the latest and greatest of the number 9 cards before they went out of business and were purchased by someone. I need to check that. But so not only the latest card and nearly latest and greatest, but also when you look here, it has a very interesting digital interface here that is OpenLDI from Sgi fame. So you could have the same connector on an SGI-O2 and with that use the famous, one of the first professional TFT displays, the Sgi 1600 SW, or what exactly that name was. Let's check that for a second. Sgi 1600 SW, yeah, I think, like I said, it's so not very many cards. You could of course use this fancy Sgi display, which, fun fact, I do not yet have, but we will see now that I have a fancy PC card with such a fancy connector. So this is a successor to DVI, again spearheaded by Sgi, and not very many displays, so only a couple of handful displays, most of which Sgi 1600 SW, and then mainly the SGI-O2, maybe a Octane V Pro add-on board, and this card nearly one of the only ones. There are adapters, so very theoretically, if you want to use this Sgi display, not only can you of course use the analog to digital converter box, or there are also homebrew projects of FPGA fame of converting OpenLDI to HDMI or DVI. Anyway, so what is also interesting for me, having here this not only fun with vintage and retro hardware, but also educational. So the Imagine 128-bit, the name says it already, gives it away, accelerator 2D and later 3D. And so there was an Imagine is a successor to the predecessor to this one. Imagine 2, and then this Ticket to Ride Revolution 3D 4. And this one adds 3D, not too bad. I would say, of course, the Voodoo certainly sold better, also because not only did it have all the platform support, but also the performance, and of course it was proven in name there in the market. However, this one here, the Ticket to Ride 4, has not only 128-bit accelerator, the Imagine already, the predecessor, already added garage shading, set buffering, double display, video rendering engine. However, this one had 3D floating point setup engine, so that you didn't had to set up the in software, previous video, we've done this for the 3D S3 decelerator, the S3 Verge, meaning you need to take your 3D world coordinates and transform them and then clip them. So all those transform and clipping is done by the hardware theoretically. And yeah, so not too bad already for 1998 or whenever, 20 years ago that was. And alpha blending, fogging, spectacular lightning, basically what the Voodoo 2 and not sure could the S3 Verge do this anyway. Allegedly maybe even a little bit of MPEG acceleration, MIP mapping of course, so not too bad for that time. And what is also somewhat interesting is that there was an open source project that was here, GPL GPU, in case you have watched that a couple of years ago. And this project was like Kickstarter or something of founding an OpenGL GPU way before the big time nowadays of FPGAs and open hardware. And unfortunately, this was not the most successful. I think they missed the funding goal. However, I have to say, of course, when this happened like 10 years ago or something, of course, they wanted to get started with something in the GPL GPU project. However, it was not the highest target goal, right? So their target was basically re-implementing in GPL in like Verilog or something, this exactly this hardware that we just have here. So this is why also twice as interesting that I got this here for us to take a look. And so although this funding was not successful, I think they funded only 30% or something of that sort, but correct me if I'm wrong. What is as interesting is also, I wanted to say this probably wasn't the most successful because this was not the highest target, right? At that time, a decade ago, we had GP, general purpose programmable, non-fixed function GPUs from NVIDIA and AMD and certainly, or ATI, and even Intel integrated. So this was, of course, a decade ago in GPL open hardware terms, already a decade old. So maybe one reason why this potentially might not have been the most successful. However, nowadays, of course, you would probably do this with some kind of RISC-V core, previous videos, right? However, there's one interesting thing is that they nonetheless, so this was supposed to be fully register compatible. So exactly what we need for this educational and fun hardware and software, so that we can write our own code. And when we take a look here in the Xorg driver, by the way, named I128 because it's Imagine 128, right? And so what is for me really astonishing now that with 20 years of experience, I look back at this and you see that although there is not a specification out there like you would find for Matrox or ATI cards or even Intel, certainly not for NVIDIA, which is why we don't support NVIDIA here. However, for this, even for this Imagine 128 or Ticket to Ride Revolution 3D4 successor, even here are quite some register definitions. So although we don't have a specification, we have really many registers, including, to my surprise, a lot of the 3D registers. So there never has been an open source 3D hardware acceleration for this. And given I look here on this, so trigger 3D, command opcode, so very similar to previous videos, S3 Verge, Voodoo, and basically take the triangle data, configure whether to shade it, to texture it, or to texture and shade it for spectacular highlights, and all this stuff. I'm really surprised that 20 years ago the big Linux companies like Red Hat, SUSE, and so on did not found here development, or nobody has done this. Although, of course, usual shout out to Robin Cutshaw, who has done the 2D driver. But to my knowledge, there never has been a 3D driver in Mesa or something, not unlike Matrox that we had 3D driver. And these cards are all very similar. I really wonder that decades ago, I have to say this Mesa code, especially decades ago, Utah GLX, was very hard to read with Macro Maze and Nightmare. even for me after 20 years of experience, hard to follow, really, not the most nicest code. What I've done, if in retrospect, it's like I not only should have done my own kernel, but should have done my own graphic subsystem, because Mesa, Utah GLX, for all the previous old projects, and also Xorg, the source code was never the very most readable. And even for myself, when I took a look there, it was always a nightmare to debug and get something done. So not surprised that nobody's done this, given that the source code was not the super most done, which I basically do nowadays. We create here with the previous videos, Verge and Voodoo, the documentation of how to program this, and I'm not here even vaporware. I've done this previously for the Verge and Voodoo, and even some 2D like Cyrus. What else have we done? S3 Trio, and a couple of others in terms of 2D acceleration. So basically what I said earlier, and why I got this card, is creating a Rosetta code kind of repository of one day hopefully of getting 2D and 3D out of there. So my goal is, let's freaking with open source code, probably never done before. I've not seen code for that, at least. Get here 3D lines, triangles, textured, hopefully. All right, also the Link 3D. What I've done previously also on the Link 3D, Silicon Motion, all the chips where I really wonder, and they also see, don't ask what big companies can do for you open source, just do it yourself, right? So do not wait for Red Hat. As we have seen, nobody has done this so far. So many definitions are here, for example, command opcode or something. Here's some 2D line, a bitbuilt line, whatever E-line is, 2D triangle, probably polygons, I mean. And then 3D line, 3D triangle. And this is relatively feature complete here, including alpha blending. And to my surprise, someone has actually done XR, this new X acceleration. You see even they use this. So they use their 3D triangle here, apparently for composite blending. Not really sure who is, maybe Adam Jackson or someone of that sort. But not even with some Red Hat or something head-on, maybe also in their spare time. So much to the big companies do something for open source. Anyway, unfortunately, I looked over this. On the first glance, it looked pretty complete. Also, I have still some drop frames. It looked pretty complete, but I was missing some things. For example, the base address register for set buffering, couldn't find it there. So I will next try to write here some demo code 2D, 3D. And then as I remembered, this project was using this. Here's GPL GPU. And I remember this from a decade ago, as you see, and do not only follow this since yesterday, but also since 20 years basically. I remembered, wait a second, this GPL GPU, did they not wanted to copy this code here basically? And lo and behold, so they have, although unsuccessful funding, they published here this technical reference manual, and this is, for the most part, quite register compatible. I'm actually not sure, probably better don't look into this now, but not to mess up here this LibreOffice thing, because sometimes it's a little bit temperamental, and you're working with the stupid docx file formats. And so what I've seen here, that all the missing bits and pieces for our 3D prototyping code, here when we look into this register, for example, 3D command and stuff, and 3D when we, okay, no, I search anyway, 3D control, and this adds up here. So when we take a look here, control register 170, and we look here for 170, this is 3D control. They don't start with this a 3, because in C you can't start here this literals with a number. So this is why they name it 3 spelled out. So 170, here's whatever, 3D control, let's 3D control, can we look here further? So this is here set E, set buffer enable bit. here 1, 0 and 1, so set buffer enable, so this matches entirely. So kudos to this GPL GPU guys, they must have had a specification. So certainly some people had a specification, because the Xorg driver certainly was written from something. So much to I would really love if all the specifications would be public, especially when you buy something that you can program it, like write your own game or microkernel. Of course, the companies, like not all, you see, S3 Verge even gave me, as when I was not even a student, 20 years ago, they even gave me the paper book. I showed this, I have it here in the office library. But I really wish that when you buy something like, say today, NVIDIA card, that you get the specification, because why not? You give them good money. And by the way, I think somewhere was in, where is it here? Somewhere was, no, I thought I saw somewhere copyright imagination. So somewhere I think I saw in some drivers some imagination stuff. But yeah, so someone, as you see here from the register specification, someone for sure must have had a data sheet. Unfortunately, I can't find any. Recurring shout out, if you have any data sheets for this kind of stuff, you can trustfully send it my way. I love to collect data sheets of all sorts. Yeah, so basically I think we have everything we need here for implementing 3D in our proof of concept stuff. And when we will do this here, I hope you find this as interesting as I find myself. So recurring reminder, I've done this for the Verge, the Voodoo, the Lynx 3D, a couple of other 2D accelerators. And now for this one, we will also do this for the Matrox, for ATI and for NVIDIA, Riva, TNT fame, all on real silicon here, for which you probably want to share, like, and subscribe, and see what we can get out of. They're also increasingly useful, because not only is EXA acceleration deleted, so this SL stuff doesn't work anymore. Also here, amazing open source stuff, right? People lose interest and delete the stuff because YOLO, nobody's using it anymore. EXA, of course, was XAA, was the X-accelerated architecture for 2D acceleration, for 2D lines, fills and patterns and stuff, and really sad that was deleted. So many people interested in keeping the old stuff working just for the pure sake of good old hardware, and really sad that especially this open source code was deleted. But yeah, it was not the most readable, which is why I'm creating here this stuff from scratch and more readable and fun. And I'm not saying that I will create the most high performance 3D code. Of course, for me it's proof of concept, but we will see. Also, this also means, as similar as those cards are, right, even Verge and Voodoo, you take the triangles, you set up those registers here as seen here in terms of, also probably this is the wrong file, just as we have done for the other cards, take the coordinates, maybe clip and triangle, set up those, and fill it into the registers, maybe for more advanced performance use direct memory access, DMA, bus mastering. And I really wonder that they, back in the day, like 20 years ago in the open source world, nobody has created such a flexible, pure, simple, because back in the day 3D was simple, right? You had only triangles, you didn't have vertex shaders and stuff, and tessellation, so it was just lines and triangles, shaded and textured and spectacular, highlighted and mapped and stuff. A couple of features here and there, set buffer control, so not too much. I really wonder that this handful of registers, that we don't have more reference, readable, nicely maintainable code out there in Mesa, and the unreadable code that was there, deleted, as I said already. But yeah, anyway, so one sad thing, I plugged this card in already, it worked, and then only today, so this card arrived a couple of days ago. So the card looks really good. I thought, hey, this looks like really dust-free. I'm totally lucky with this auction. Came from the USA, by the way, which also have here. Which camera view would this be? Would it be that one? No, it's not this one. So only real with some map outline there of the, not even made in the USA. But what is really sad, only today I noticed there's a memory chip missing. I have no idea how this happened. And on further inspection on the auction there on eBay. Unfortunately, the eBay auction already had this missing. So it's for sure, it's not 32 megabytes, so it's probably like 30 megabyte or some. So also the PCB is quite scratched. There's so much to overpriced auctions of vintage hardware, so quite destroyed there. And I wonder, so next I'll probably start writing a memory test for VRAM. So I hope this is the last IC missing. I tested this. It's posting. It booted in this Syn client here that I usually use, transmitter efficient previous video Syn client. It booted into Linux. Xorg driver was not amazing because the Xorg driver deleted code of previous acceleration fame. But yeah, somewhat sad. The problem is also, I looked already a little bit closer, that these pads are even missing. So I have no idea what's going on there. I can only suspect either this is manufacturing defect, so maybe this card is like trash to treasure. Because this, I'm not sure if, so either someone has desoldered the IC, the memory IC, which I find unlikely. Probably, maybe it's more likely that it is a manufacturing defect and this card actually already is like on B stock pile, or I don't know. Or really or maybe as it is scratched there, maybe someone desoldered it so crappy and didn't know how to operate a hot air station and maybe scratched this there with a screwdriver, like maybe going in there with a screwdriver, lifting off the IC. I don't know. Thankfully, the card is good enough. Well, unfortunately, I only noticed after giving them a positive eBay review so much too. You can never wait too many days. Previous video, I auctioned MT32. Buttons don't work. I auctioned this. Only 2 days later, I noticed memory RAM IC missing. It's like, can't mix this stuff up. Yeah. So with these two pads missing, there is just a through-hole wire, so maybe it would still work. So next I start writing a memory test and then I do the bit build here. I hope this is the second 16 megabyte. Maybe we are so lucky it is the last memory IC, but we can't be that sure because the numbering is a little bit strange. So when we take a look here, the numbering is like U8, so the numbering is not linear, as you see. So U12, 13, so 11, 12, 13, 8, so whatever is up with the numbering. So I have no idea which part in the memory map this memory is now missing, but one thing for sure is that it's not 32 megabyte. So yeah. Anyway, we will see how this is going. So first I write a memory test, basically our DOS low-level Verge Voodoo proof of concept card there from previous videos to see where in this linear memory this is missing. I can only hope it's a higher 16 megabyte, maybe even higher. I hope 24 megabyte are okay, but we can of course work around this in our own code. It's certainly, such a card is certainly a bit of a pain, which by the way it was advertised as 100% working and tested. Using this in Windows of course could lead to blue screen of death and other game lookups if a game is allocating video memory and the memory is not there, it's writing there, reading there, and zeros come back or ones come back. Certainly, yeah. Anyways, this is also a recurring reminder why you don't want to spend so much money for vintage and retro hardware on eBay. But now with this rare card, I'm somewhat a little bit tempted to get such an Sgi OpenLDI display. I hope you enjoyed this overview and a little bit of vintage and retro stuff of what existed, not only in exotic hardware that few people heard about because most people nowadays only hear AMD, Intel and Nvidia. But yeah, there have been other companies, and given, by the way, I think maybe the companies, they would have survived more, a little bit of my humble opinion, and because, for example, the Sound Blaster stuff was highly compatible, also previous video of programming that, and so there were many Sound Blaster and VGA card clones, and maybe the 3D companies, the initial ones like S3 and Number 9, maybe they would have been still around and NVIDIA wouldn't exist if they would have made their stuff compatible. Yes, they had drivers. It's a little bit the fault of there was Windows or OS2, and they had these drivers and they were hiding all their hardware complexity and bugs and features behind slow and buggy drivers. But if they would have come up with, if they would have sit together and made a VGA 3D standard, and all the cards would have had the same register as in this ones here, how to program this of this kind of fame, and which, by the way, this is exactly the stuff that NVIDIA is not releasing, and recurring, giving NVIDIA here a hard time and shout out that this is not amazing. That, in my opinion, if you buy something, you should be able to program it, although there are Windows drivers, buggy and slow and drivers and stuff. But if you want to use it on Linux, see in the Novo fame, but also if you write your own operating system like Haiku, BSD, Minix, and Rust OS there of Radox fame, then or our microkernel, you need some specifications. And this is also the reason maybe why Linux, or for sure Linux, didn't take as much off as it did 20 years ago. Certainly we would have had more desktop Linux if 3D and graphic performance was more outstanding, and we basically still have the same issue in Linux today, that for a decade there is talks of a Xorg successor. The old 2D acceleration code is deleted. We only have this new XR, not XAA. And thankfully we now have AMD and Intel open source drivers and a couple of more, but the vintage driver is also deleted. And yeah, basically desktop Linux certainly for 2 decades suffering of not the most perfect graphic subsystem, which certainly also in parts because specification often so rare. And yeah, if this would have been compatible, if imagine a world where there would have been VGA 3D, cross company vendor model register specification of all using this same registers to hammer 3D triangle data and stuff in there, not only would the original companies probably still around instead of NVIDIA, and maybe open source desktop would have been much more amazing with much better support, because certainly 20 years ago or 10 years ago it was always an issue. If you have a random card, it probably doesn't work amazing in Linux. So yeah, leave in the comments what you think. Leave me also in the comments if you want to watch here hours of live stream, me typing in here all the registers and trial and erroring until textured 3D triangles come out of there. For now I will probably do this off camera, like put it into the transmitter efficient sync client that I usually use this for this here now, and network booted my previous setup, DOS TCP stack, of course, later on microkernel. But yeah, this code is open source already for the other cards, so if you want to write some amazing hardware 3D demos, games and operating systems, be my guest. This is what I try to build up here, some repository of driver code, readable and maintainable driver code, and yeah, some stuff that otherwise is deleted in upstream open source projects. As you see there, I also got a couple of more cards, but this is probably a topic for another video. I hope you enjoyed this video so far and learned something of stuff, history, and how stuff works together, and also not only what kind of hardware connectors existed once upon a time, but also recurring theme here, how this works. But again, don't repeat this each and every live stream. So previous live stream in terms of registers, but to summarize this, basically you take, even for this 20-year-old vintage hardware, you take the coordinates of your 3D world and model, maybe triangle setup it or not, depending on whether your hardware does triangle setup, bit BLT this or bit bang this into these registers like X, Y, and Z, and configure texture and stuff. So actually not rocket science, or not really, maybe a little bit rocket science, but not too difficult. And basically everyone could have done it at home. I'm really surprised. There, of course, historically have been some 3D drivers, ironically, even for Riva TNT by no one else than less than John Carmack of Doom and ID fame. But yeah, due to the transitions of Utah GLX, Mesa, and DRM stuff, a lot of code lost, a lot of acceleration lost, really sad, but yeah, that's what we are here for, to dig it out of the Computer Chronicle historic fame here. So yeah, thanks for the comments, everyone. Let's see, what do we have here? Some comments in the audience, emulator, assembler, fun stuff. Does it mean would be able to run the GPL on an FPGA then use this open source driver? Yeah, so I've not checked how complete this is, but theoretically, if this GPL GPU, no idea if it's complete, I've never tried this, but if it is complete, yes, you could do this, exactly. Probably we could take into there another look, which, by the way, fun fact, we could take a tiny little look now. But by the way, if you take a look and find how complete it is, leave me in the comments below. Let's see, is it here some subdirectories of VGA math, and where would graphic core, not sure where they would have had. So it's at least Verilog. Let's see, can we, okay, this is okay, only instantiating some module, which, fun fact, we can of course much easier read now with our many FPGA videos already, which another one today of homage on Game of Life here on our RISC-V graphic core. Where would be 3D? So I have no idea if this is complete here, something of 3D. Gen, color, scan line, 3D maybe. Yeah, anyway, the code, yeah, on the first glance I don't see here the most high-level code where they calculate something, but also this is code looks interesting, so to say. If you evaluate this GPL GPU code more, leave me in the comments below. But my goal is, I will, in the long term, in the short term, I will, for this handful, what we have done previously, S3 recurring reminder, S3 Verge, Voodoo, I will do this next, Matrox, ATI, NVIDIA, so the major chips, maybe in the next 50 years to come, maybe nearly all of them. Also, if someone wants to donate an Sgi IV Pro, I still miss this for my Octane. But otherwise, I will create some code, like one header file, like reusable header files that you could reuse in your OS or demos, and with the same API, so that you could source the file for the Verge, the Voodoo, the Imagine 128 Matrox ATI to come, and write your own demos or windowing subsystem. And we will, of course, for our own microkernel and stuff here, have the own windowing server, middle layer that can use any of those, like instantiate any of those, and have this 2D windowing here, like this windowing fame, do the clipping, the painting, texturing and stuff. But yeah, let's see, what else do we have there. Chase, looks like you can get those RAM chips on eBay. May work around the gap. Yeah, so the problem is, this is what I was thinking. The only problem is there is some, of course I was thinking the same. The only problem is it's a little bit scratched there. And so these pads are missing. I think I mentioned the pads are missing, right? So these two pads are missing exactly at the through-hole wires. So you probably could bridge that over there. Basically there, right? There, these two pads are missing. So I have no idea what happens there. If this is a manufacturing defect or someone looks, because it's so scratched there, maybe someone desoldered it. Maybe someone was so desperate to need a memory chip, which is of course never do this, right? I mean, this is hilarious, destroying such, especially with this OpenLDI digital connector. And so these pads might be bridgeable. It looks like the through-hole wires went probably to these pads, which does this look like maybe is it the same? Well, I would think probably the through-hole wires probably where is my screwdriver? This is probably bridgeable. What is a little bit more of an issue is this there. I have no idea if this pad is important or if it went somewhere, but maybe not. But yeah, maybe depending on where this memory, if the memory, well, certainly this memory is missing. Again, first I will now write a memory test because it's what you're doing. But yeah, let's see where this hole is, and then depending on how important it is, if this memory hole is very early, I will probably try to solder a memory chip there. If this is in the very high, if I'm so lucky it's at 30 megabyte or something, I probably leave it as it. It's not like we're running Windows on this card anyway. I'm not the greatest Windows fan. And vintage gaming, maybe I just take another card. And for our own card, we could actually include memory VRAM testing in our own driver stuff. So to like memory size it automatically and report like, hey, this card should have had 32, but it doesn't work there, so not use it. So again, on Windows, it could be a problem. Maybe you could force Windows driver with some registry or ini tweak or something or whatsoever to use less memory. But yeah, 100% tested on eBay. Well, that's what you're getting. Anyway, welcome everyone. Welcome to Tart. Hope you're all doing fine. What else do we have there? OpenGL is a good standard, but so the thing is with OpenGL, of course, all those cards are advertised as OpenGL or Direct 3D, but this is only a software standard. So many people always think this card is doing OpenGL. No, they aren't. The only card, probably the most likely nearly only card in the world ever that did OpenGL in hardware was the Sgi V Pro, previous video, Sgi Octane, because they had a microprocessor there on the card that directly accepts GL commands and is doing all the triangle setup and all the GL command interpretation on hardware, as far as I've seen via reverse engineering. All the other cards, they accept registers like this. So this is not GL or Direct 3D. This is custom register level, nothing really with Direct 3D or OpenGL. The only thing is the driver takes the API interface data and transforms it so that it fits into those registers there, which is also not the right document, but this here obviously, or this. But it's just that the hardware implements features required for a certain OpenGL or Direct 3D level in terms of texturing, multi-texturing, triangle setup, texture transform and lightning and stuff. And the driver usually one-to-one passes on the data relatively directly, but it's not OpenGL or Direct 3D in hardware. They are talking about forking Mesa, also legacy cards, so less breakage. Yeah, so a little bit of look up, as we already discussed it, a couple of. So as you see here, but probably I leave it also here, next videos. There are a couple of Utah GLX drivers that never made it to Mesa, including Verge 3D. So for me, forking Mesa, unless you fork a decade old, because they already removed support for Matrox, MGA, and whatnot, that was perfectly working 15 years ago. So, so for all the earlier generation cards, the code is already long removed, and also in the Xorg server, the XAA, X acceleration architecture, this 2D acceleration long gone. And so unless you fork something from a decade ago, you still don't get this back. But anyway, the code I recently, the last night, looked at Utah GLX and like, oh my god, this code. It's a crossword puzzle of macro maze fame. Not nice to read and work with. So yeah, this is probably I rather do my own. I'm probably fun fact. So with this, for people who tell me it's too complicated for NVIDIA to release a specification, and this is also why I vote with my wallet and not buy NVIDIA stuff. With this kind of hardware, especially this generation here of 2D, 3D accelerator, with this kind of specification, it usually takes me about a day to, with this kind of stuff, unless I need to look for some really stupid bit that's missing, like some really crazy stupid thing. 2D and basic 2D, a couple of hours to get this working, like a proof of concept, right? Not like full-blown X driver, but proof of concept 2D commands are basically working. like a couple of hours usually, and 3D probably a day for 2D and 3D commands, like basically like what I've done previously. And as more it saddens me that support for such kind of early rasterized 3D triangle cards is gone so much and didn't, for the most part, not exist much. But that's what we are here for, to fix history or Back to the Future style. And let's see. Detailed believes XVR100 also did OpenGL in hardware. It depends. XVR sounds like Sun. Depends what exactly this was. Some ATI need to check, but it is possible that there are others, but the only one I know about is Sgi V Pro. And let's see, 3D engine, that what are we there? Another comment. Engine sucks. At that, do you have an OpenLDI? DVRC asks OpenLDI monitor. No, I haven't. I'm somewhat tempted to maybe auction an Sgi 1600 SW, but why are you asking? Do you have one to donate? Of course, they're not the cheapest, and the backlight, of course, after 2 decades, a little bit faded, and yeah, they are stylish and stuff, but they're a little bit pricey just for the YouTube video stuff. But maybe I get one, because why not? Well, I have time to show. Windows, you mean spy bloat? What are you saying? Believe something. So OpenGL driver take advantage of something. GF sucks and native triangle rendering, amazing stuff. So what we will also do probably another day is on our RISC-V board with the ULX3S. Probably we implement some graphic acceleration another month later this year, maybe in autumn, with BLD, and maybe we actually implement triangle shading and texturing just for the educational fun. But that's what I have for you today. Now I plug in this card here, which by the way theoretically, which also is that. So in this FunSync client, also I tested this already the other day. This graphic chip becomes relatively hot, at least in the Syn client. So which is, yeah, there is no fan inside. So you probably want to have this with a case fan, which probably for the vintage testing, I probably should install a tiny little fan here in the Syn client, just because. But previous videos, pretty nice little setup. The only way this would be better if the Syn client had the PCI riser on the other end, that it's a little bit, yeah, but it's fixed here a little bit with this metal indentation there. So it's, oops, also live, always breaking the Syn client here. But yeah, network booting this here with this nice yellow cable, and then edit compiler on this Linux with GCC for low level, running this bare metal low level on DOS, and until we have our own microkernel. Nice little test setup, I have to say, and probably we should really eventually have a tiny little fan there for stuff. And also, let's hope we didn't break it, thankfully. But yeah, the only thing is, also the difference with many other channels would just plug it in there and play some games. The difference, of course, we actually use this and program this. I hope you enjoy this different kind of context to really see this in action and how to write code with it, and that it is not such a intellectual property, highly top secret thing that NVIDIA wants you to believe it is, and that everyone can do it at home there for your fun to play along at home, modifying Xorg, Mesa, Linux kernel, or your own. That's it for today. I get to work with that, and I hope you learned something, and to see you soon for the next videos and live streams to come.